What is up, people, and welcome back to the channel. Right, so I'm gonna let you see where we're at, what we've been doing, what I've been doing, and where we are on this chassis. So we've done a little bit more since the last video, and I didn't record it because it's just simple. I always say that, don't I? It's simple, but depends, I suppose, on the caliber of the engineering skills, I suppose. But anyway, so here we are. Hang on. Oof. So in the last one, you saw me put these two in, yeah? And then what I've done is I've done this one. I've put this one in. So this one is simple. It's 2 notches, and it goes. You get your mark to where you want it to be. 2 notches, nice and simple. Nothing really hard about it. And once you get the one side done, the other side's about the same. And then we have our X. Now this X has a few purposes. So we are mounted to the center of this tube. So we are, hard to show you, central that way to this point. We encapsulate all 3 pieces of material, this one, and this one. And the same on this side. Then this is a brace. So if it was a flat brace, just flat say to that bar, you would have pretty good rigidity this way, but not much this way, if you know what I mean. I mean, it's not going to move with these anyway, but I'm just trying to explain the reason upon why it sits up at an angle. See? So if I try on my phone square to the table, for instance, you can sort of see just how much it goes up, yeah? And this one goes up, and this one comes down, this one down. So if this bar was square, it would be easier to move up, but it's not. It's like this. So to get that to move up that way will take a tremendous amount of force, because all this is triangulation, and if that's square, and we had a square line, you could have a bit of flex, because it's going up. You've got to try and shorten that one and lengthen that one whilst trying to lengthen that one. It's not going to happen. But then, because this comes up at such a high angle, that bar there is also stopping this bar coming up. So that bar is stopping it coming up, but it's also stopping it going in, and it's stopping it coming out. Do you understand what I mean? And for this to even come this way, you've got to move this top one. Well, that ain't going to move because that one's being held in by these. So that's why that's angled. If you had all flat, it's like if this came across here, it could go up. So if I just put a bar across there, this can move because there's no structure. Yeah, you've got to have some support structure for your chassis. So all of this is well thought of and designed for the purpose of what we needed to do, which is to hold this and this there. Even in an impact, it's got to hold. Do you know what I mean? It's like if you impact something here, yes, it's gonna give, depending on how hard you hit. That's the nature of the beast that we build. But for that to go in, yeah, that's got to go in. So it's got to push that, which is also connected to that. So it's got to bend that. But then to bend that one, it's got to move all of that structure, which is also combined with this structure. Do you know what I mean? Everything has got redundancy built into it. So to move one thing, you've got to move something else, which is attached to something else that's got to move as well. So that's why that I've really got... Didn't I get really in a tangent then? Way off. So anyway, this goes up to stop this coming up, as well as the rest of the stuff. And that is just a basic X, the same as we did the back. All notched. I notch everything. Even this 1 inch, some don't even notch it. Yeah? I notch it. Even the 1 inch to the 45. which is barely nothing. Notch it. I just notch. Everything is a nice fit. So I know now if I drop this subframe off, it will just go back in. Because none of this is going to move. Now, if I'd have had unnotched and there were gaps, when you've welded all this up, it will pull in. Only 1/4 mil either side. It's 1/2 mil. And this ain't going in. Do you know what I mean? Right, so anyway, that's what we've done there. We put them in, we put our X in. These are my steering rack mounts, which I've been making up. This is my master copy, if you would say, my master copy. And we've got 3 for 3 chassis, and then this one is slightly shorter, which is for Les's car, because the Knights Motorsport front subframe is slightly narrower on the top radius arm mounts. So radius arm mounts, top arm mounts. So these 3 are mine. So same as we did those brackets, drill through 10 mil, and then there's a 16 mil sleeve inside. So this is opened up to a 16 mil, and then in there is solid sleeve all the way through, 16 mil OD. So it's nice and big. TIG welded all in place, so that when you come to put your bolt in, we are a nice fit, yeah, on the 16 mil inside. Everything's welded up, the end's capped off. And whether you remember, what goes on there is these are my billet steering rack mounts that I make. So this goes on the back side of that. Catch my drift? Steering rack. So yeah, these are steering rack mounts. I'm still got to put the ends on, which I brought the wrong ones. I brought 8 mil. It's massive. So I've tried to get the 6 mil that I normally use, because I put the wrong bloody ones. So anyway, yes, that's them done. And I've been on my radius arm mounts, look. So I'm going to show you a little bit of what I've been doing with my radius arm mounts. So these all start off as this stock, which I have bent for me. Yeah. So this is 3 mil wall, 3 mil, 100 mil, 50 mil. Heavy, it's heavy duty stuff. It's not thin. It's really good quality mild steel as well. Then I cut them down to this. Yeah. Which is like 210 mil. So then we end up with 4 chunks like that. Then I shape them, right? So this one gets a bit chopped off here, which is, yeah, I'll get one of these ones as well. So this gets cut off there. That's our 100 mil. Yeah. So we set that off there. Then this is the part that came off here, but I've already started modifying this because I use this for something else. And then the big one is, this comes off here, and a little one comes off there, which are all down there. Then all of this gets marked for my slots, because as you can see, we've got really nice 1/2-inch slots and holes. Exactly where everything needs to be for our toe and camber. Now, to get all these marked up correctly, I use my little manual height gauge, which you basically just set a ruler, you get it near as damn it, and then you've got a fine adjust here to get it to where you need it. And then wherever you need your mark to be, it's like you can just about see this line here. So when I did all of these, I had it down. This was obviously lower, and I just scribed across. So I'm scribed on all of them, all the dimensions that needed to be, even these holes in here got scribed so they were in the perfect spot. Then we run them through the milling machine. So these, it's like this setup here was for these. So I had to stop, and that's when I put these holes in last. But when I did the slots, it's sort of the same thing. You make up yourself a little jig, so everything butts up against a stop. In, mill, nice and simple. There is a video already on my YouTube a couple of years back of me making said brackets. So what I'm going to now, I'm going to set you up over there. I'm going to show you me putting one on for you. So this is why we take our time on our precision. These are 10.0 holes. Yeah, M10. Just fit. Yeah. Precision. And then one goes in. 2 goes in. That is 0 side to side and up and down movement. So yeah, that's that then. So right, for my adjusters, I've made a load of these washers. No! Bagger. I've made a load of these washers. Basically, these are my washers for my adjustment. Now you might say, Mr. Skidmore, why are they so big? They are big. They are 4 millimeters in dimensions. And I'll show you why. This is the brackets, yeah? Oh, nice and big. These basically compress that steel. As many people know, on the inside, I think these are the small ones. Have I got any of the big ones knocking around here? Just thought I did. This is my old spanner drawer. Everyone's got an old spanner drawer. I think they're actually on this car. Yeah, they are, look. See them? So these are the small ones, but there's also bigger ones. See, they're not that much bigger. And the idea is, one of these is on the inside, yeah? And then the big one goes on the outside. So you are fully compressing this, yeah? Either side. A small washer, you're not covering much area on this side. I want to spread the load a lot. You get me? So we've got a nice big size washers. Over-engineer, yeah? Yeah, I mean, it don't weigh nothing. It don't weigh nothing, so it's not a hindrance on the car. But it's spreading the load so much more efficiently. And how much more surface area is touching this surface area to grab on. You know what I mean? So, that's that. This is my adjuster knob. Yeah, so basically I did have one here that I'd already ground down. I think there it is. Yeah. So see how I've ground the one edge down? They will all be the same. Yeah. Now I'm going to make a new jig. So it makes these repetition much easier. But this basically is going to get welded onto there. Jig welded on. Yeah. And this will have an 1/2 inch hole in it. But this has to be in the right position, yeah? It has to be perfectly straight with that washer. If it's off, it won't adjust. That's an exaggeration. It has to be perfectly central and square, but also flat, yeah? So we're going to make a new jig just for this. And then this gets chopped up whole, which will all get done in the milling machine, to the desired height of this bolt. Yeah, and then this gets bent up and they get welded on here for the adjuster to go through. But then this has to be dead square and central with the slot. Yeah, so in the next video, it's going to be us building these. We're going to make a jig. We're going to weld. We've got to drill holes in them. We're going to weld these up. We're going to make these. And we're going to fit them on. We're going to make a jig or some sort of tool which slots into this 1/2 inch hole, which helps me align the bits. I'll show you what these look like. See them? There's my finger. There. These. That there. That's what we're going to make with this material. So we need a jig that also will hold these, because the hole that's in this plate has to be dead in line with that slot. Otherwise it won't adjust properly. So yeah, there's all little things like that. And then we've got these. Now I only started doing this for looks, really. And normally I put a triangle in here. Yeah? Like a triangle. Triangulation. Then I thought, what if I did that? Put a bend here. So that is bent like that. And then it gets fully welded across, up and up. It just adds that little bit of a more flair to this, which otherwise is quite a boring part. And then it gets another triangulation in about here somewhere, just for extra bracing. Yeah, triangulation, boxation everywhere. These get two. They get one at the top and one about here. So yeah, in the next video, we're going to finish up making these. There's a video way back in the day, but this, we need to make some jigs. We need to do a bit of machining, bit of lathe work, bish, bash, bosh. You get me? Right. Thanks for watching. I hope you're enjoying the content. If you want to see anything else, bang it in the comments, you know what I mean? And yeah, I'll see what I can do. Oh, and look, I'll put the seat in the middle. I wish you could have a single seater. Imagine how much space we could have with a single seater in the middle. Freaking wicked, wasn't it? Right, catch you in the next one. I hope you're loving the videos, and see you later, people. Bye.